You are welcome to the Scholar School. We establish our footprints on the sand of time, experience the difference.
Hi, welcome to the Scholar online class. My name is Abiola Daniel Olamide. So I'll be taking us through mathematics today, and our topic here we have sets. Actually, it's Venn diagram, but it won't be that okay if we just move to this Venn diagram. So we have to make it sequential. Now, what exactly do we need to know? Not about Venn diagram, but about sets. Actually, many people have discussed about these sets in different kind of context and anyway. But set on its own is talking about the collection of a similar materials, or probably it could be people, it could be numbers, and it could be anything. For example, when we have a library. Now it could be the collection of books in the library. So set is talking about the collection of things that has similar characteristics. That's what we need to know about set. And not only that one alone, we also have the different types of sets and ways in which sets can be represented. For example, when we have a set, it could be defined in different kind of ways. We have sets in form of this. Now, this is a way of representing sets. This is a way of representing set. You have the set of x where x is less than or equals to 3, where x is less than or equals to 3. That means they are actually telling us that the values of x here, they are less than or equals to 3. That means you are starting from 3, yes, 2, and what? And 1. And not only that, there's another thing we need to know about the set, which are these things I wrote here, the numbers. They are called the elements of set. Elements of set. Now, what are the elements of a set? The element of a set are the members of a very set, are the members of a particular set. For example, when we take for example Nigeria, considering Nigeria to be a set, the collection of people in Nigeria becomes a set. Now, what is not the element? The element of set Nigeria is not talking about the people present in Nigeria, which are the citizens. So that's just the simple explanation for element of set. And another way to represent set, we have the diagram way of representing set. That is when you have it presented in a table. You have it presented in a table, then having all its elements present in that table. That's another way of representing set. And we also have the types of sets. Types of sets. We have the identity set. That means or equal set. We have the equal set. We have the equivalent set. We have many of them like that. Now, in new general mathematics, we also made mention of some other types of sets, like something related to the union of sets, the intersection of sets. Actually, that might not be the types, but it's talking about ways in which sets in which we make use of sets in mathematics. Because you can't just talk about it in that context without explaining what deeply and how it relates to mathematics. You know, when you have the union of sets, that is actually talking about when you are bringing two sets together. For example, set A and B. When you have set A and B, now when we talk about union of sets, we have this U here to be the union. When we talk about union of sets, it's talking about the combination of two sets together. Actually, it is the combination of two sets, but what you actually need there is the element. For example, when you have set A having the element to be 1, 2, 3, and 4, and you likewise have set B to be 2, 4, 6. Now, when you take a look at this, if you are asked to find the union of this set, all we need to do is to combine them together. I gave it a 10. I gave it the LCM. Earlier before now, we had the knowledge of LCM. The first thing you need to do is to choose the one that is common to both. Then after that, those that you neglected that doesn't have any similar characteristic with the other one you are corresponding with. Now, when you have A union B, you have it to be. Now, here we have 2, here we have 2. That means you only choose it as one. Here we have 4, here we have 4. You choose it, you take one. And others that doesn't has any identity in either of the elements, we take them likewise. So we have 1, 2, 3, 4, and 6 as what? As the union of the two sets. Likewise, intersection. For intersection, I give it a term. I gave it the ACF. You know, in our knowledge of ACF, all we always do is to find those that are common, right? Those that are common. Here, when we check our elements of set A, you have your 2, 1, 2, 3, 4, and element of set B, you have 2, 4, and 6. Now here, when we talk about ACF, all you need to do is to choose the one that are common, right? So here, all we need to do, and there is an identity or something that represents the intersection of sets, which is something that looks like our N, then our B. Here, when you check well, you see there's a particular element here that is also present in set B, and there's another element here which is 4 that's likewise present in what? In set B. So we are only picking out those elements that are present in the two sets. So you have 2 and 4, and many other things like that about sets. So we have the representation of sets, the element on itself, the set, the union of set, the intersection of set. Now, back to our course for today. We have the Venn diagram. Venn diagram. What exactly is Venn diagram? What exactly is Venn diagram? Venn diagram is actually a way of representing sets. No, I talked about the diagram method of representing sets. Venn diagram is one of the aspects of the diagrammatic representation of sets. In Venn diagram, they give you probably an event that happened in a particular place, or probably they give you a kind of scenario where you represent it in form of set. For example, I can take Nigeria, I can take Algeria, and I can take Zaria as 3 sets. Then I will now start like merging the element of the set together, then form a kind of story and ask us to find one way or the other something that relates to this intersection and the union of sets. We might be asked to find values. Most of the times in our schools, you know, in every school, we all have like different choices. For example, I have a friend, Bola, who actually doesn't like rice, and I like rice so much. And I also have another friend who likes rice and likewise also like the food that my friend Bola likes, which is beans. That means, you know, with what I just gave out now, I can make a kind of manipulation, then present it in form of set. That is actually what Venn diagram is talking about. I like rice, then I can consider myself as set A. I like rice, so automatically I'm giving it an element. And likewise, my friend Bola doesn't like rice, he likes beans. He likes beans. So I have my friend B, he likes beans. Then I have my friend Suji, he likes rice and beans. You know, I can present this in a set. I can present it in a set. That is when the Venn diagram comes into place. And we are going to solve a perfect example to balance that understanding. Now we have the question here. Quite simple, right? Okay, let us solve it. Now we have out of 548 students, 162 read the guidance and 124 read the Vanguard, 320 read neither. The question number says illustrate in a Venn diagram. You know, we explained earlier, the first thing is to be able to understand the question on itself. Now, there's something about set which we are going to recall is the universal set. Now, actually here, when you study it very well, we have a universal set here, which is 548. So, to present this, represent it in a Venn diagram, all we need to do is this. You have your big table. Then your universal set, which is 548 students. 548 students. Now, we have 162 students read the guidance. That means the guidance is a set under this. So you have your big circle, which is representing the guidance. I give it G. Now I have 162. That means 162 students read the guidance. We have and 124 read the vanguard. That means that is another set entirely. 124, which must intersect with the guardian. 124. Okay. 124. Then after that, I have 320 read neither. Now it's English. When we come across this neither, it's telling us that we have 320 students who doesn't read both the guardian and the vanguard. So we have them outside the set we have here, but still in the Venn diagram. So we have 320. Now we say the question says illustrate in Venn diagram. So to illustrate this, so you have this here. You have illustrated this in a Venn diagram. Actually, there are still more things you have to peruse here. Now, which is in question number 2. It says how many students read either the guardian or the vanguard. That means it's telling us find what? G intersection V. The G intersection V, which I explained something about the intersection earlier, what is common between the two sets? Actually here it's telling us who are those that read guardian and likewise vanguard. So we don't know them, and anything we don't know in mathematics, we give it an identity. Now let us give it an identity what? Identity X. That means the question is find X. And we also have to understand something here. Saying that 162 students read guardian doesn't mean 162 students read guardian only. Because we are having intersection. So we have to remove those that what? That read only guardian only. By subtracting this X from 162, and likewise for vanguard, you find those that read the vanguard only by subtracting X. Now with that, we are going to go in solving this question. So to find X, all we need to do is to be able to sum every values we have within the Venn diagram here. Is to be able to sum them all together, then equate it to the universal set. So in this case, what do you have? You have 162 minus X, okay, plus our X plus 124 minus X plus then those that didn't even touch any of the vanguard or our guardian plus 320. Then you equate it to your universal set. 548. Now, from here, all you need to do is to open your brackets as usual in mathematics. We have 162 minus X plus 124 minus X plus 320 equals 548. So here, minus X plus X will be eliminated. So you have 162 plus 124 minus X plus 320 equals 548. Now here you can add this together. So you have 286 minus X plus 320 equals 548. So you can still add this together. When we add this together, we have 606 minus X to be 548. Then when you take this to the other side, like collecting like terms, you have minus X to be 548 minus 606. So you have minus X. So here we have minus 58. Then when you see this very well, you can see that the minus sign can eliminate. In mathematics, that is one of the law of identity element. So here minus eliminates minus, you have an answer to be 58. Now, so with this, we've answered our question. The question says, how many students read either the guardian or the vanguard? So with this, we have X, which is the total number of students who read the vanguard, and likewise the what? The guardian. So that is how to solve questions like this. At times you might have questions having 3 elements. All we need to understand, key number one is to be able to interpret. Yes, when you check very well, the first thing I did was to interpret the question. I interpreted the question, then I got my Venn diagram. Then the next thing I did was to assign values. Yes, the next thing I did after the interpretation, I assigned values to each of my sets. The first thing I named my set here with G, which is representing our guardian. Then the next thing I did, I represented my set here with set V, which is my vanguard. And after that, I gave out values. They said 162 students read guardian. So I put 162. Then after that for vanguard, I put 124. Then after that, I made mention of our element, our set, our element X. X representing the total number of students who read both guardian and likewise vanguard. After assigning values, then the next thing is to solve. Actually, most of us always have this kind of mindset that immediately we see question, immediately we open our pen and start solving. That doesn't actually mean you are solving. The first thing you need to do after you have interpreted, after you have assigned values, then that is when you cannot begin to solve. Once you miss the interpretation, then to assign values will be wrong, and to solve you end up getting the wrong answer. And that is all about Venn diagram. Example 2. We have in an attempt to determine the most popular commercial city in Nigeria. Some places across this country were interviewed. 50 responded that they like Kano, 60 Port Harcourt, 44 Lagos. Also 5 said they like both Kano and Lagos, 4 said they like both Port Harcourt and Lagos, and 3 like both Port Harcourt and Kano. If 200 people were interviewed, how many like all 3 cities? The first thing is to interpret this in our Venn diagram, put all values in the Venn diagram, so you have this. The last statement in the question makes us understand that we have a universal set, which is 200. Now we have set A, which is our first city they interviewed, which is Kano. We have set B, which is Port Harcourt. We have set C, which is Lagos. Now, we have 50 responded that they like Kano, so we put 50. 60 likes 50, 60 like Port Harcourt, so we put as 60. 44 Lagos. Now then the question continues. It said that 5 said they like both Kano and Lagos. 5 said they like both Kano and Lagos, so that is the intersection. So we have this. Then the next one says 3 like both Port Harcourt and Kano. 3 likes Port Harcourt and Kano. Port Harcourt and Kano, that is 3. Then we also have 4 said they like both Port Harcourt and Lagos. 4 likes both Port Harcourt and Lagos. Then the question says how many likes all the 3 cities? That means find X. The way we solve the questions when we have 2 sets in a Venn diagram, that's the same method they are going to apply for this. That means the first thing you need to do is to find what those that likes Kano and Port Harcourt only, those that like Kano and Lagos only, those that like Port Harcourt and Lagos only. Then we move to those that like Kano only, those that like Port Harcourt only, those that like Lagos only. And to do that for this first 5 here, all we need to do is to subtract X from 5. So here we have 5 minus X. Then the next thing we do, for 3, we subtract X. So we have 3 minus X. Here for 4, what we do is to subtract X from 4. So we have 4 minus X. And likewise for Kano only. So all we need to do is to take our 50. So we have 50 minus, then we add all this together, you have 5 minus X. So as to manage space, we can just write it on our new side here. So we have the first one, Kano only. We have Kano only, we have 50 minus the summation of all these. We have 3 minus x plus 5 minus x. So we have 50 minus. So here we have minus x. This will be eliminated. So we have 3 plus 5, that is minus 8 minus x. So here you have 50 minus 8 plus x. So here you have 42 plus x. As the total number of people who like Kano only. Then the next thing we move on is those that like Port Harcourt only. So for Port Harcourt only, we have 60 minus the summation of all these. You have your 3 minus x plus 4 minus x. So here you have 60 minus this will be eliminated. So you have 3 plus 4, that is 7 minus x. So you have 60 minus 7 plus x. So here you have 60 minus 7, that is 53 plus x. Those that like Port Harcourt only. Now for Lagos only. For Lagos only, we have 44, then we subtract all this. We have 44 minus 4 minus x plus 5 minus x. So this will be eliminated. So you have 44 minus 4 plus 5, that is 9 plus x. So here you have a 35 plus x. Now, so the next thing we are going to do is to now add all these values together. So here is for Kano only, we have 42 plus x. For Port Harcourt only, we have 53 plus x. For Lagos only, so we have 35 plus x. So we add the values together to find our x. So then we equate it to what? To the universal set, which is 200. So we have 200 to be equals our x first plus 4 minus x plus 5 minus x plus 3 minus x plus 42 plus x plus 53 plus x plus 35 plus x. So here you have 200. So we have x minus x eliminated already. Here you have eliminated already. Here you have this eliminated. So you have your 4 plus 5 plus 3 plus 42 plus 53 plus 35 plus x. So we add all this together. So you have 400 to be 200 rather to be 4 plus 9, that is 4 plus 5, that is 9. This 11. This 9. This 12. This 54. This 54. Then we have our 54 plus 50, this will give us 88 plus x. So here you have 200 equals 54 plus 88. That is, here you have a 2. Here you have 13. That is 152 plus x. So our x here will just be equivalent to our 200 minus 152, which is equivalent to 48. So therefore, those that like Kano, Port Harcourt, and Lagos are 48. So these are to solve question when it comes to 3 sets in Venn diagram. So thanks for watching the Scholar online class. I hope you enjoy our class today, and never forget to like, subscribe, and share.